anecdotally warm. It's walk down the street having to wear actual human person clothes and not like a pair of shorts, and it's too warm. And
Okay.
stormy. Warm and stormy. That's
So it's 21 and stormy. Is that what you're saying?
sure. Yeah, why not? It's an amount of stormy. It's an amount of warm that is uncomfortable, and we don't need to quantify it.
Okay. That is the most interesting answer I've given. Okay. Well, it is currently about what 66 degrees and almost 18 Celsius, I guess, or 16 Celsius here in Seattle. Yes, sunny Seattle. So goodness gracious, I know people might be surprised that we actually might have decent weather here. So we've got the YouTube up and running, so that's good. So now we're just waiting for LinkedIn to kick in, and once we get that, we're good to go. Woohoo. Oh, hello from Texas. Excellent. We've got some Texans here. I guess for the person from Texas, that's going to be even hotter, isn't it? At least that's my guess.
I mean, something's wrong in the world if London is warmer than Texas.
That's very true. That's very true. My goodness. All right. I believe we have LinkedIn up and running. Give me 1 second. All right. Perfect. I think we are. Oh, yeah. Artavan from Texas has noted it's 85 degrees. So that's a little on the warm side. Okay, perfect. We are up and running on LinkedIn and YouTube. So if you have questions, by all means, please start asking. Let me go ahead and stop sharing. And then, perfect. So for everybody that's wondering, this is Simon and Denny Ask Us Anything. Now, we do paraphrase the comment that when we say ask us anything, it is within the realm of data engineering, Delta Lake, lake houses. Okay, so it is ask us anything related to that. I mean, I guess you could throw in some coffee for me and baking for Simon, but nevertheless, that's the context. Okay, so saying that, first things first, why don't we just introduce ourselves? Simon, why don't you start?
Sure. Hello, I'm the Simon half of Simon and Denny Ask Us Anything, I guess. I thought I'd qualify. You know, you just said you were half. You didn't let us know which half. It's important to know. Yeah, so I'm Simon.
I'm the lazy half. Maybe is that what I am?
I think that's a challenge. That is a highly contested half. Yeah, I run a company in the UK called Advanced Analytics. I do lots of data stuff. I do Microsoft-y data stuff, and I do Databricks-y data stuff. Yeah, that works.
All right. Thanks very much, Simon. Okay. And then myself, my name is Denny. I'm a developer advocate here at Databricks. As I go ahead and bust my mic. I'm a longtime contributor to Apache Spark and also Delta Lake. I'm also committed to Delta Lake. Prior to that, prior to Databricks, I was also at Microsoft, and you can blame me for things like HT Insight and SQL Server and Cosmos DB and things of that nature. So lots of data questions. That's what you're here for. So let's dive right into it. So now, as this is an Ask Us Anything, we do ask you to prop your questions directly into either the Q&A or to LinkedIn or to YouTube, okay? And so this show pretty much will run based on the premise of the questions you ask, okay? So do note that. So in other words, this thing could end in about 5 minutes if you've no questions. By the same token, we can also iterate and talk about lots of really cool things related to data. So one of the first things that we actually got, one of the first questions, because you can also send questions via LinkedIn directly to Simon and myself, was basically, or tweet us for that matter, was can we dive a little bit into star schema migrations into Delta Lake and data warehouse best practices? So Simon, you want to start tackling that one first, and I can definitely add some color coding to that?
Yep, absolutely. I mean, it's one of the ones that we've had lots of people going, yeah, but you still don't do the star schema bit in lakes, right? And we're like, yeah, we do. We do all of it in a lake. That's the whole point of a lake house these days. And yeah, so there's an easy way to do it. There's a real straightforward way to do, how do I get my star schema working in my lake? Well, you take the SQL that you use to do it elsewhere. I mean, you just run that same SQL inside a Databricks notebook. You just run it as Databricks SQL, and it's the same thing. You know, you can write your insert statements, your merge statements, whatever you use to make your facts and dimensions, and you can lift and shift and run it in Spark. The majority of that is just going to work. You know, there might be a little bit of syntactical changes. I don't want square brackets. I want backticks around my long column names, that kind of stuff. You can't have recursive CTEs. But apart from that, the majority of things, and if you've got a massive recursive CTE in your dimension model, there's something a bit weird. You get so much of this stuff, and you can just lift and shift it over. Now, don't necessarily say that's the best way of doing things, because if you had 50 stored procs sitting in your SQL database that you're using to make your kind of your existing warehouse, and you just turn that into 50 different Databricks notebooks, and then just ran that, I mean, you're missing out on some of the nice parts of performance and tuning and engineering. So a lot of the time we take that SQL logic and we'll put it into a more generic Python notebook. We'll have a bit of PySpark that says load data from somewhere, transform it, land it somewhere with partitioning and do a proper merge and kind of manage it for you. And you just kind of take that same SQL and just run that as, put it into a PySpark, data frame equals spark.sql, run that SQL, or have it as a view that you select from, or have it as whatever it happens to be. We tend to separate the business logic, put some SQL over there, and then a real generic just kind of wrapper saying, get some SQL, and then land it properly in a nice governed, performant, happy way. That's how we do it.
Perfect. Well, so adding to that, so one of the things that I often will talk about is that it sort of depends on what environment that you're starting off with first. Okay. So for example, if you're starting from scratch and your source data is relatively small and you don't have that much different varieties, you may actually not need a star schema. In all seriousness, you can start from the standpoint of just the data. I know. I'm hurting poor Simon on this one. I apologize for hurting him like that. And no, dude, I came from SQL Server and all I did was promote data warehouses. So calm down, buddy boy. Okay. Now,
I said nothing. It was just Ralph that was silently judging you.
No, I know. But the context is that in order to get yourself up and running, it's not a necessity to do that, because the whole reason we talked about star schemas, especially for online analytical processing or OLAP or data warehousing design in general, was the premise is that we actually were trying to be extremely efficient with our joins. Okay, so that way they were, especially during the older days, this is aging myself, but basically the idea was that we could utilize memory more efficiently by ensuring the joins were being done by primary keys and foreign keys, or whether we actually did actual primary and foreign keys, but logically primary key and foreign keys, using integers. So that way those joins could be very efficient. And by only storing integers at worst case big inside the fact tables, you basically were reducing the size of the fact table as well. So that was the initial impetus, okay, of why we built star schemas in the first place. And so a lot of the logic I just said isn't necessary, especially when you're starting off. But okay, as you progress and as you build more complex systems, what usually ends up happening is that, for starter, your dimension tables aren't necessarily stored in the same system that you're actually processing in your lake. You may have some third normal form design, or you may have some operational data store that actually controls what those dimension data sets actually look like in the first place. And so because of that, your dimension data, where you keep what ultimately is, remember a star schema is comprised of a fact table with a bunch of dimension tables. Okay, that dimension data may be organized or controlled by some other system. And so because it's controlled by some other system, you'll end up needing to build a star schema anyways, just because you're going to be extracting the data out of this other system. And then because you may not necessarily have full control of the system end to end, what will end up happening ultimately is that basically you'll have to do exactly what Simon just described, which is that you'll actually need to go ahead and all those design patterns, like data warehousing design patterns that you normally would apply to data warehousing, the actual techniques, even though you're not building a data warehouse, you're building a lakehouse, right? The actual patterns of a data warehouse are still very much applied to your lakehouse design. Did I cover everything? And do I make up for the fact that I nearly caused you a heart attack, Simon?
I mean, yeah, I absolutely agree. There's one thing that is upsetting me at the moment.
Oh, okay, sorry.
Really upsetting me.
Okay, I apologize.
And it's a Databricks naming thing.
Okay. Well,
why are Databricks SQL endpoints being renamed to SQL warehouses? Come on.
I got nothing on that one. Yeah, I got nothing. I'm not marketing. That's
I mean, that's fair. That's
fair. Yeah. So don't look at me. I have plenty of answers for the technical side, for the marketing side. don't have any answers. And so let's include the ask us anything, no marketing questions, because I can't do those. I'm sorry. I apologize.
Yeah, I mean, so that absolutely makes sense in terms of how we're building those out. The one thing I would say is that we do challenge Kimball. Yes. Kind of it's not saying that, a lot of Kimball, when it was designed about how you design that star schema, it is absolutely designed for a relational system. There's loads of things that we keep because it's good to manage data that way. Having things like a slowly changed dimension, or dimension modeling. If I've pulled out all the information to do with this dimension onto that separate table because I'm doing some data model design and I need to update something because something's changed, I can do that by updating one record rather than updating every single record in a 10 billion row fact. That's way more efficient. So there's loads of bits of data modeling that just makes a lot of sense. But some things that we used to never do, like, the cardinal sin of designing a star schema, if you put a string on a fact, you're a rebel. You get kicked out of data modeling school. It doesn't matter so much. It's a little bit more forgiving. The good compression and dictionary management of Parquet is a little bit better, so you can do that kind of thing. So I'm a little bit more laissez-faire with my kind of Kimball modeling rules. I'm not the dictator that I used to be about how well you should design and how well you should kind of conform to the Kimball modeling principles. It's you keep the bits that make sense because they're good for data management. The bits that we did because it was a problem of relational, you no longer really need, and we can challenge it. So it's take the stuff that makes sense and apply it to the new technology.
Oh, so you're asking us to actually, think about the process. Yeah. Oh, sorry. Okay, gotcha. So
just blindly do what we've been doing for the past 20 years.
Exactly. One thing to note, this is just a shameless plug. And Artavan, who actually originally asked the question, called it out. Douglas Moore and myself actually did a couple of sessions or 3 sessions about data warehousing techniques with Delta Lake. The session I'm particular that Simon's calling out, particularly that is related to what Simon's calling out, is the one related to surrogate keys and type 2 slowly changing dimensions. So we actually have sessions just on those two, and I am proud to say, as a nerd, that I made sure the entire session was related to Stargate SG1 as well, and Stargate Atlantis. And yes, because it's important for us to get that in. So I just want to call that
Makes
out.
sense. Yeah.
Okay. So as a quick follow-up, because otherwise you and I will keep on talking about this particular topic. Okay. So we're going to stop now because we have other questions and we're going to actually try to answer some of them. But let's do Artavan's question, because he also has a follow-up. Okay. Which is migrating from Spark 2.x to 3.x. What should we consider while migrating our star schema? Let's start with that one.
I mean, for me, it was 2.x. You didn't really build a star schema because it didn't really perform that well with joins. You couldn't do predicate pushdowns over partition joins, and it wasn't very good. So you used to have to do really designs like making sure, essentially, pre-Spark 3.0, I spent most of my design time trying to trick people into, including the actual partition column in their the filter predicate of their SQL statements. That's how I spent my life. Trying to go, no, ignore those columns. Use this nice shiny column that you really should query. But after 3.0, especially after adaptive query execution and dynamic partition pruning went in, you can do things like have a date dimension and have people filter the date dimension and have it work out that, actually, I can take that filter context and apply it over to my fact. And it just works. So it's less of a what should you consider when migrating. It's just it'll actually work as opposed to not work so well. Yeah.
No, I think the one thing I would definitely add is which I'm a huge fan of, is basically the adaptive query execution, AQE, that actually speeds up performance, and it is designed very much with more of that particular like data warehousing design in mind, right? And the my favorite part of AQE is skewed. So basically the Spark 3.x actually solves that for you. There's actually nothing, I was going to say solves it for you, but does a great job handling skew so you don't actually have to subpartition the data yourself. Specifically to your question, Artavan, there's really nothing you need to do. It just happens because these are the learnings from the Spark community itself, that basically over time, as more and more people build these complicated systems that are lake houses, on top of Delta Lake, the context is very much that there's more of this type of logic placed directly within Spark itself to help out. So, okay, cool.
The one thing I'm casting my mind back, a couple of years now, I think there was the minor thing that tripped us up was date dimensions that were generated. We had to change the case sensitivity of the various different date formats. I think that was the only major thing that actually tripped us up in taking it literally a lift and shift. Suddenly it's like, oh, it's case sensitive now because it's gone ANSI standard.
That's right. That's right. Yes. And then for table column names as of Delta 2.0, you can accept so long story short, the reason why you couldn't have spaces, it couldn't have capitalizations, though frankly capitalizations sort of suck anyways, but is because Parquet itself didn't accept it, but then with Delta 2.0 onwards, basically accept there's a mapping that was actually introduced in Delta 1.2 that now allows us to go do that. But again, these are minor things that actually just make things a little bit easier for you more than anything else. That's all. So cool. Ready for the next question? Because we've got somebody from the UK asking. And by the way, for the folks, we see your questions from Jeff and Hilbert, somebody anonymous, but there's one from Graham that we want to tackle first, just because it's from your neck of the woods. Okay. So want me to say it? Yeah, I'll say it. Okay. Yeah. Hello from wet and windy Blackpool in the UK. So there you go for your neck of the woods. I'm using Delta Lake on Azure Synapse to build a lakehouse against data versus data. What is the best way to generate surrogate keys with Spark? He saw my and Doug's tech talk about surrogate keys a couple years ago. Again, the one that includes references to Stargate SG1 and Stargate Atlantis. Have your views changed?
Yeah. Yes, kind of. And it was the thing. I was teasing Denny before the stream with a question of my own, which is, so we used to build surrogate keys in a couple of different patterns. You can do it with a row number window function, and that involves a little bit of sorting, and it's like performance. Or you could do it with the monotonically increasing ID, which is a fantastic name, which is super performant, but just has it's very sparse. And if people like their surrogate keys to be nice, 1, 2, 3, 4, 5, 6, which they shouldn't, because they should never see it and never care about it, but people want it to look nice. But so that was always the two options. It looks the performant way, the tidy way. But these days, Delta, you've got an identity column. So if you have built a Delta table before you insert data into it, so if you do a create table as and specify the table properties and specify column properties, you can say, have an identity column, and then you just insert data into it, merge data into it, and it manages its own identity. So the same way as you would in terms of a normal SQL database, you would have an identity column. I mean, I know this is like what, 2 months ago, 3 months ago, identity columns came in.
Yes,
people from SQL Server land are like, welcome to the year 2000. But it's great that we can do that now.
Yeah. And so, and the call outs, like, which is funny, which is like they say, but like, welcome to year 2000. The funny thing about the statement is that, yes, within an SMB, a single system within SQL Server, since I'm from SQL Server, okay, it's possible to do such a thing. When you have a distributed system where each of the workers actually need to go ahead and generate a unique ID, that's actually a lot more complicated than people realize. And so, yes, it took a little bit longer for us to go do that. There is actually a great session. I'm actually pasting it in. Let me paste it in the chat so y'all can see it. Oh, where did my chat go? Oh, there we go. All right. This is the one I'm pasting right now into LinkedIn and YouTube is Simon's video about identity columns in Delta. Okay. And then, of course, if you wanted the previous history, where, like I said, there's references to Stargate SG1, then I'm going to go ahead and paste my and Doug's version of that as well. So I think that should cover those two scenarios quite nicely. So, all right, so that should cover us on surrogate keys for now. Let's go ahead and go to the next question. All right, let me go to LinkedIn first, because otherwise I'm going to forget what people are asking here. What are the biggest challenges in Delta Lake for real-time data refresh?
I mean, joins, realistically. So in terms of how we design lakes, you know, you talk about bronze, silver, gold. So not what I use, but bronze, silver, gold is fine. Having bronze and silver real time, great, easy. Because you tend to have a one-to-one mapping between a data set comes in, we put it down, we pick the data set up, and we clean it, we get it right, and we get it all ready and validated, we put it down again. Now, having that single line of hops, dead easy to stream, things just work, Yeah, you have to manage it. You have to like sort of optimize it. You have to look after it for the small files problem of Parquet. You're constantly inserting small things, but that's all fairly simple. The moment you say, right, and then I want to join these 5 tables together to make something like a fact, things get really complicated because it depends on the window, depends on the kind of the temporal relation of those different things. How much state are you having to keep in the memory of your Spark cluster to actually get that working? So the majority of the time, for pure brutal simplicity, we tend to have things going full real time up to that kind of silver layer, and then have just incremental rebuilds of the gold layer, or kind of just every 15 minutes, every 5 minutes, whatever it happens to be, saying take everything that changed, pull that over. Just because trying to do it as Spark structured streaming, you've got limitations as to how many streams you can join together, and then a stream to static or static to stream, and there's just different constraints about what you can achieve there. And if you're asking people to do it from a business point of view, from a data analyst point of view, kind of you've got all your data, your dimension designs, and fact designs, and saying, oh yeah, just be aware of this giant pile of streaming logic and streaming kind of limitations. It's a big ask. So that's how we tend to do it for simplicity.
Yeah, I can't overemphasize Simon's point enough, which is often more times than not, it's actually the business logic. It's not to say the technical logic is difficult. It can be quite the opposite. Okay? Quite assuredly, it can be quite difficult from a technical perspective. But what usually happens is that the business that's making the request doesn't actually understand the implications of what they're asking. And so because they don't, then the people who are trying to build it, the code ends up getting much more complicated. And what you're trying to do, just like Simon called out, is you're trying to simplify things. You're trying to make things as easy as possible. So that way, it invariably, when the system breaks down, all systems break, right? That it's really easy to reboot, restart, refresh, whatever. The other quick call out that I would also say is that when you talk about refresh, it really depends on that statement, that word refresh actually means different things to different people. Okay. So for example, somebody from a business might say refresh means everything from bronze, silver, gold needs to be completely cleaned up, versus some maybe analysts is just saying, oh no, just need the gold table refreshed, right? So with the former, which is everything needs to be refreshed, is basically you're taking everything from the raw data, and because you've decided, for sake of argument, the business logic, what used to be coded as red now is blue, all of it needs to be rebuilt. So every silver table, every gold table, all the machine learning, all the analytics that went with it, all of a sudden had to be rebuilt. Now, be forewarned, more times than not, that's actually not what it means. That's just what they think it means. Okay. So, and then the latter being, oh, no, I just need to do a change to a single table from silver to gold. And that actually requires just some business logic updates. That's all that is. Okay. So, or modifications. I should probably be very specific with my wording here. But the context, nevertheless, is that it's that business logic that really comes into play that really starts messing you up. So that's what we more times than not, when people use that word refresh, you have to be very careful of what that actually implies and what that entails. Does that make sense?
Makes sense to me.
Perfect.
Final thing on that. So if you're going through your bronze and silver and you're not kind of rebuilding your gold, you can always just point your reports to hit silver. And whenever someone says hit go, they then recalculate those things on the fly, and the report takes a second or two longer to make, but you're not actually having to recalculate everything on the fly or refresh everything on the fly. So there's different patterns, right? It's about deciding what needs to be updated.
Excellent. Okay, so let me switch to YouTube before I go back to the Zoom here. And this is actually related to Hilbert's question from Zoom about DLT and DBT. So do you recommend using data modeling tools like DBT instead of a bunch of transformation notebooks? So you want to give it a shot first, Simon?
I don't have a strong opinion on DBT, honestly.
Okay.
So because we've already invested in terms of the stuff that I do, I've already built a lot of transformation notebooks, and I tend to be lifting and shifting existing SQL to kind of then just plug it into it. So for me, DBT doesn't make sense for what I'm doing in terms of my state of code. I've seen a lot of clients who have great success in terms of using DBT and applying some of that kind of the principle to template out the logic for it. But I don't have a huge amount of hands-on experience with it yet. It's on my list of stuff that I need to spend a lot of time digging into. So yeah, no, I can't really say too much about it.
Okay, well, but by the same token, that's actually the valid answer, right? Because a lot of the times when it comes to using systems like DBT or DLT, which is related to Hilbert's question about DLT, okay, and just using notebooks, it really depends on where you're coming from, right? So, for example, often the data engineering persona is one that they're using CLIs and IDEs to do all their development. The data scientist is the one who uses notebooks, right? So for sake of argument, if you're, or data analyst for that matter, I'm sorry. So if you're typically a data analyst or data scientist that has a lot of SQL statements or Python statements, using that as an example, it may actually, in all seriousness, make complete sense to go ahead and just use notebooks for those type of transformations. By the same token, if you're coming in from, and by the way, DBT is great for that because the whole purpose is to write everything in SQL, okay? By the same token, if you're coming in from like, no, I really need an IDE style or I need CLI, this is where I'm saying, okay, well, then maybe I want a CLI system. Maybe I want to use DLT or in some cases DBT or whatever else to do that. And so really, honestly, the context is very much where you're coming from and what tools you're already used to using. So for example, if you are a Scala IDE developer, then you typically use IntelliJ. Honestly, that's probably where you're going to come from. You're going to come from that aspect, right? Versus if you're going to go be a Python developer, you're probably going to be perfectly happy inside the notebooks. Okay, so hopefully that answers that question from YouTube. Now, this flows into, are there big differences between DLT and DBT? Right away, I'll take that answer since I've used DBT a little bit. Yeah, I mean, there are very big differences. Delta Live Tables is very much about the structure of Delta Lake tables within the context of Databricks right now, okay? Right now, that is, okay? Now, in the case of DBT is great for using SQL statements on multiple different sources, okay? So DLT, is very, its design is very centric about how to simplify the streaming and or batch processing. So it's very much this context of you're coming from Spark, you're coming from Delta Lake. Now, how do I go ahead and abstract away some of the complexities around using different environments? Basically, write the code once, apply it to different environments, you're good to go. In the case of DBT, on the other hand, it's very much about saying, okay, let me use SQL statements to go ahead and apply to all of these different databases, all these different systems, source systems. And so there definitely is some intersection between the two, but they're actually really designed for two different environments. And hopefully that helps answer that question.
I've actually sort of only in the past couple of weeks, a few clients have actually mentioned a pattern that they're trying out, which is actually both. So DLT for the earlier data pipeline, data processing kind of bits. So using autoloader in Delta Live Tables to bring data into the kind of the early raw bronze layers, using Delta Live Tables to do the cleaning preparation stuff, the repeatable, obvious kind of cookie cutter stamp steps, which are more apply some Python with some parameter kind of things, doing that in Delta Live Tables, and then handing off to just a DBT job, which you've now, is it as of this month, you've got DBT jobs in Databricks workflows?
That's correct. You do. Very much so.
So they can run. See, I'm keeping up with the release notes.
Yeah, I know. You're reading them. Actually, in fact, you're reading them better than I am. So so it's pretty good, actually. Yeah.
So being able to do that and have a DLT pipeline run through all the different kind of programmable, automatable stuff, and then run a DBT package, which has got more your design and your kind of your warehousing and your modeling kind of stuff, actually just run this, when that's finished, run that, seems to make sense for those guys. Again, it's real early stages of people talking about how they're doing it, but it doesn't seem to be a either or. They just have different benefits.
Rock on. Okay. We got plenty of other questions, and I realize we're probably we're going to try to solve them in the next 15 minutes. So let's go do this. Okay. We have another question from our buddy Greg Kramer from YouTube. He's asking us a question: is there a relation between DBT and Fivetran? There are lots of tools. It was easier when we could just handle data with everything, all the data with Excel. And so, you want to comment, or you want me to comment first on this one?
I will let you take that one.
Okay. So Greg. Okay. So Greg's an old friend. In terms of all the different tools, I'm probably not going to go ahead and be able to explain DBT versus Fivetran in a decent enough way. Okay, these are great tools that are allowing for connectivity to different source systems. The fact is, there's a lot of systems out there, a lot of different orchestration systems, a lot of different development systems, and so we're probably not going to be the best people to explain all that stuff. Honestly, we will actually have sessions with DBT and Delta Lake and Fivetran and Delta Lake and all these stuff in the near future, but they'll be more appropriate for that type of discussion. But what it comes down to, and the part that I will is that yes, it was easier when we did everything in Excel, and part of the reason why I'm laughing at that particular statement is that Greg knows I was one of the first demos I did, actually, by the way, when I was still at Microsoft, was to basically get Excel to connect directly to Hadoop to actually bring data down. And that's true when you're dealing with less than 65,000 rows, the old 65,000 row limit in Excel. As data has gotten larger and there's more complexity and it's gotten much faster, the reality is, while Excel is a great end tool to look at this stuff, the reality is 95% of our problems are much more related to everything before that, as opposed to that little tidbit near the 10 end. So much as I do agree with you. Yeah. Sorry, go ahead.
I'll tell you, it was easier when we could do everything in Excel because the data was a small enough problem that it could be done in Excel.
Yes.
It's the fact that we're doing larger, bigger, crazier, we're doing things that are real time. We're doing things that are dealing with horrible, nasty, gnarled, nested JSON. The fact that we're doing mad data sciencey stuff. I mean, you couldn't really do that back in those days. So yeah, it's gotten more complicated. And yeah, the environment, you've now got lots of different specialist tools and they're just distributed and then they evolved and then you pulled it back and now you have 6 tools that can do most of it. But yeah, there's interesting times. Keeps us entertained off the streets.
It definitely does. And Greg's just wanted to call that he's getting into his Databricks journey. His multi-year goal makes a lot of sense. Yeah, you can keep on asking us questions. All right.
Welcome. Join us.
Exactly. Join us. Let's go switch over back to Zoom here. Jeff actually had early on asked this question. This is a longer one, so I'm going to say it, but I'm going to say it a little slower so that way everybody can hear it. So, good morning. I'm using Click Replicate. It's a CDC tool, and also Dynamics 365 to push to a data lake. Okay, both create incremental change files in an Azure storage account. Okay. In both scenarios, the initial and any subsequent full load files land in one folder and change files into a second folder. So full load files in one folder, change files in a second folder, okay? He'd like to use autoloader to ingest to a bronze delta table, but how do you best account for 2 source paths? Keep in mind full reloads versus the that could be ingested after the fact, plus the fact that you still have change data capture. All the above.
I mean, it's a pain. Essentially, you need to have a switch in your notebooks that look after it. Essentially, it's 2 separate paths. I mean, whenever we're doing an autoloader load, we'd have a single notebook that does that anyway. So you're saying load from autoloader, and I'll tell you the folder path, I'll tell you the details, I'll tell you the schema to expect, and all that kind of stuff. And then transform it and land it into whatever bronze table you're dealing with. Essentially, something would have to do to trigger the run of the historical. Something would have to run to trigger a run of the incremental. It depends how you're using autoloader, because I think compared to the Databricks true standard, if it's a streaming tool and it should just be turned on streaming all the time, I use autoloader like a criminal and just turn it into a trigger available now route and just run it as an incremental batch one. It's just a very easy one for me to batch data in. So it depends on how you trigger in it. If you just leave it turned on, if you leave it streaming, so you essentially have 2 parallel streams running, which could be the same notebook, but just executed in parallel with different parameters put in. One saying this is my historical stream, one saying that's my incremental stream. But there's an overhead, right? There's a cost of leaving that historical one. If that's just sat there streaming, waiting for a full historical reload that might never come, that's a big overhead to have sat on your Spark driver, constantly running micro batches going, any more data? No. Any more data? No. Any more data? No. So I don't tend to do that. I tend to split it up as, two parallel streams, but I have another mechanism that triggers the full reload and build that into the logic of whatever orchestrator you're using.
That's great. I don't think there's much more I can add to that. Okay, we got tons of other questions. Let me try to get into them. Okay, next one from Hilbert. What is the best way to start with a framework to make your notebooks more generic?
Give away my secrets. Yeah, I mean, so there's loads of things you can do. Essentially, it's getting used to whenever you write Spark code, whenever you write a bit of PySpark, if you have a choice between doing something that can be parameterized and something that can't, do the one that can be parameterized. And there's a few little tips and tricks with that. So making your spark.read command generic is, don't use the implicit file formats. So don't do spark.read.csv, do spark.read.format, pass in the string CSV, which means you can pass it in as a parameter. .load, pass in the path. So to get used to try and build your spark.read, it's fully parameterized. Pass in the options config, pass in things, get used to passing anything in. Transformations, we had a lot of SQL. So you can use the expr function as a kind of the Python command, allows you to just dump a string in there. And if that string can be passed as a bit of Spark SQL, then it'll work. And that means you don't, in your logic of your notebook, you don't have to say, I'm going to change this column, I'm going to apply this calculation to it. You say, apply something to some column, and then you can start to make it generic. You can start to inject strings at real time and make it very, very generic. And then at the end, your spark.write, or your dataframe.write, has the same things. You can make that generic. You can tell it where to go. You can tell it how to put it. You can tell it whether to use Delta or not, or just not include a format, and then it'll use Delta automatically, but then you're a criminal. Yeah, so you can get through those 3 steps, and that's what a generic notebook is, right? Read something, do something to it, write it somewhere, and if you break your entire data pipeline up into lots of steps like that, so you're not having these big notebooks, which is all the different transformations I need to do to generate my 20 tables in my data model. Each element of your data model is a single notebook that runs independently and is entirely generic. Read something, do something to it, write it out. And if you can start to build in those paths, you can basically start to parameterize anything. And your notebooks, kind of the majority of the lakes that we deal, if we're talking about going from bronze to silver, silver to gold, we tend to have maybe 3 or 4 notebooks, and that's it. Everything else is just parameter configuration, run it in a loop, run that same notebook 100 times with different parameters, and you can clean 100 tables at once. How we do it in a nutshell.
Yeah, that's great. Okay, I've got a bunch of small little questions that I'll go ahead and just tackle them off right now. Let's see. Okay, first one from LinkedIn from Agnieszka. I apologize if I did not say your name correctly. Is Delta Lake views, can they be registered via data catalogs like Calibra? In general, when you register a Delta Lake table, you're registering it into something like an HMS, a high metastore. You can often do it with things like Glue as well. There's actually a Glue Delta Lake connector that was released, I want to say 2 months ago, I believe. There's also Azure Purview integration, and Data Hub recently released theirs. I don't believe Calibra itself currently has one, but it would not be that complicated to do a plugin. So one of the things I usually ask people that if you have ideas for connectors like Calibra or anything else, let us know. Join us at go.delta.io/Slack. Okay, that's the Delta user Slack. Chime in there with your ideas, and then we'll track them. Or either that, or go to the Delta users Delta Lake GitHub, excuse me, as in go.delta.io/GitHub, and then you can go ahead and just chime in there with your ideas. Because more times than not, that's how we're getting ideas as the Delta community to go ahead and actually add these different integrations, just basically based on the Slack messages and or based on GitHub issues being created. Okay, so hopefully that answers your question on this one. Let's see. There was another one. Oh, Artavan, you had asked that the circuit key version with the notebook isn't available. Bummer on that. My apologies. So do me a small favor, Artavan. If you can just either ping me via LinkedIn like you did before, or open a GitHub issue, and then we'll go tackle that ASAP. So my apologies for that one. Let's see. There's another question from Schema from YouTube. She or he, I apologize. You had asked if a specific thing about Delta sharing. This one's a little bit more complicated. So what I did is I did a response saying, please go.delta.io/Slack. There's a Delta sharing Slack channel. by all means, ask us questions there, because then we'll have a bunch of the Delta sharing folks there to help you get everything up and running. Avishek asked the question, when will the Delta Lake Definitive Guide be published? We're still working on it. It's been, with everything that happened with Delta 2.0, we end up delaying writing because half of what we wrote was changing based on Delta 2.0. So now we're actually going through the process of trying to get ourselves up and running with that again. All right. So those were the quick questions. Let's see. There is a great question from Dennis or Denis from LinkedIn, which is there a known or good strategy for how often run vacuum and define file retention values depending on your table update frequency?
No.
What do you think?
It's very much, and it depends. How often do you change the table? How much of the data gets touched in each incremental upset? So because currently, whenever you update, if there's a Parquet file that gets changed as part of an update action, anything that didn't change now is copied into another Parquet file. And low shuffle, like the delete's gotten better. So it's now actually kind of just low shuffle merge and all that. If you're doing upserts, copies the records that didn't change separately, so you might protect them. But then if they get changed in the next one, you're still going to have multiple copies. But like incremental upserts do create lots and lots and lots of redundant copies of data. But if you're doing a daily update, probably don't need a daily vacuum. You can probably get away with a weekly vacuum. If you're doing streaming and you're updating that table every 10 seconds, every 60 seconds, maybe it's actually touching a lot and your data volume just exponentially growing. So it's always kind of how much are you touching it? Kind of how many times a day are you updating that table? And therefore, how many extra redundant copies are you doing? If you're streaming and it was append only, so you're not actually making any records obsolete, it's fine. You don't even need to vacuum that table because you're not going to have anything going and updating those changes. It's very much what is the update pattern for the table and how much of the data gets copied into a redundant obsolete file each time you update it.
Perfect. Okay, we actually probably only have time for 2 more questions, and both are a little bit of a doozy one, so we'll try our best to answer these questions. First one's from Shaman from LinkedIn. The question is, what is the best way to handle configure information for your silver layer batch processing? So do you have any advice on that?
Best way to handle what?
Configurations.
Configuration.
Yes.
So depends what kind of configuration that we're talking. So we're talking about things that we'd kind of correct. One of the things that we were talking about earlier is what comes first, the table or the update statement? Because a lot of the way that we used to build these things is the dataframe.write command would implicitly create the table. So you can apply table properties, you can do lots of things in that, just in the write statement. And so we'd have kind of various things built in to go and do that. And then we switched things around and we said, well, actually, we're going to start you doing a merge because we've got merge now and Delta, and there's just an easier way to do things. And then actually, so table level properties kind of need to exist before we can do a merge. We can't just run a merge statement. It'd be lovely if the merge statement auto-created the table if it didn't already exist. But currently, we have to create that table.
Yes, you do have to create the table. Yes.
So if you have like table level properties, if that's the kind of configuration we're talking about, table level properties you need to create when you create that table. So you normally have a separate little function, and we just generate some SQL in there, kind of a create table as here's all my columns, here's my density column, here's my partitioning, here's all the relevant information needed for that. And we just do that as a separate little pre-command and then have it behind an if statement going. Does the table already exist? If not, go and create the table. Here's my table. Other configuration, if it's more like what transformations, it depends on how you've built your own framework. That's where you want to keep your metadata.
Perfect. There's probably a lot more to this, just like what Simon talked about, depending on what the definition of configuration is. So since we're pretty much almost out of time, but I still want to at least try to tackle 2 more questions. I'm going to chime in and say, please join us at the Delta user Slack. I'm going to paste it to everybody here, so that way you can just join and ask us questions there. But let's dive into the final question. Actually, there's one still quick question that I'll answer right away, and then the final question, which I think is interesting for us. there's still a question: was Z order introduced in Spark 3.x, or was it there before? And the long story short is Z order is actually specific to Delta Lake. Well, actually, I should rephrase that slightly. There are Z orders in other systems too, but in the context of data lakes themselves, it's not a Spark thing. It's actually a data lake thing. So Z order was actually existing within Delta Lake within Databricks itself. And we recently open sourced it as part of Delta Lake 2.0. Okay, so now it's available for everybody to work with right away. Underneath the covers, we're talking about how it basically reorganizes the data with sparse filters. I'm not going to get into that right now because we don't have much time, but we can definitely chime into that next time if you want to dive into that. So
we'll put Hilbert's speckling curves on the next AMA. That'll be fun.
Exactly. That's fun. We're fine into it. In fact, all I'll do is I'm just going to grab TD in my session. We'll just paste it there and we're good to go. All right. But this one I figure we want to answer because I think it's a great question to end the session. It's from Naveen. Is in Delta Lake, how do we handle data deletion? That is in scenarios like write to forget data or data consent withdrawal. We need to have time travel for other records. For example, if we have if we have 1,000 records, you have to time travel for the last 15 days. But if those 10 of those records need to get deleted today and you do the vacuum, all of a sudden, basically, you remove all the last 15 days of data, right? So what is the right balance on how you approach that problem? So I've got some answers and you've got some answers. So why don't you go first?
Why always me going first with the hard one?
Because I'm the one answering the question.
It's fair. It's fair. You're doing the admin.
I'm doing more talking than you right now. Deal with it.
Yeah, I mean, so GDPR certainly for us in Europe is an issue, right? Most of the time, it's not an immediate. Someone rings up and says, "Hey, I want to be forgotten. Get rid of my data," and you have to get rid of it at that moment. There is a reasonable period for you to enact that request. Now, so if talking about 15 days worth of kind of data retention, that should be covered by the amount of time that you've got. As long as you action that request, you do the deletion, and you are keeping a short enough period in terms of your time trial for that to reasonably be forgotten within the realms of that. That's okay. That's usually fine. I mean, it depends on the rules that you're in, depends on the country that you're in, depends on the data protection legislation that you're actually under as to how big that window needs to be. But you can't get around it. If you have to delete that data, you have to vacuum up to that point and you'll lose time travelability up to that point. There isn't really much you can do. We've seen some interesting things that people have done to try and get around it, which is less keeping the data, but keeping the data in an obfuscated or encrypted state and then storing an encryption key elsewhere. So you actually, at real time when you're querying it, you use the AES decrypt function to decrypt the data. Then if you delete the value for that, that's gone. And then actually your actual table still has its time travel, still has everything, but no one has the ability to decrypt that data. Therefore, the data is technically destroyed. If you cannot reverse engineer what that data is because your key is gone, it kind of gets around the problem, but it means you then have to join to that table and decrypt, and it's a performance issue. So you can build it to be incredibly robust and just kill it immediately using decryption stuff. You can just increase the amount of vacuum you're doing. You can build into your processes and actually just talk to your data protection auditors and go, is this amount of time that I've got? Because I've got a 15-day backup of my database, kind of. That is normally absolutely fine in terms of how those things work. I did have one thing which is a challenge, is in terms of the log retention period also needs to be considered. Because if the right to be forgotten, if the PII information is in your minimum maximum statistics, that's also a PII no-no. So if if it happens to be there, so it's like, don't take stats on PII columns. It needs to be something you're thinking about. Therefore, it needs to not be in your first 32 columns. And that's kind of, there's a few things you need to be careful about if you're doing a full, we are following regulation data protection to do with all of this stuff.
Yeah, and just to add to Simon's point, this is a very complicated system and really depends on your legal department, engineering department's definitions of how they follow GDPR. So, for example, one company that one pattern that I've worked with is that they've identified what is deemed as PII and put them as a separate Delta table. And in this case, it's basically, in essence, it's a demographic table, if you want to think of it this way, right? So basically all the PII is placed into these 3 or 4 demographic tables. So what ends up happening is that they actually will not delete, interestingly enough, they'll specifically redact. And so in other words, let's just say ID 20, name Simon, okay? And so what they'll do is they'll actually keep the ID 20, but they'll change the name from name to from Simon to redacted. The reason they do that is because there's downstream systems that they don't control, that they actually have to make sure that are aware of it. So they actually have to keep the ID. So they know that ID 20 was the one that actually specifically redacted, and they trigger downstream systems to basically say, oh, we got the word redacted now. Go ahead and clean up the downstream systems as well. So even though the Delta Lake, the data lake, is actually completely cleaned out by that, because in essence there is little to no history actually on the demographics table, because that's the whole point. They need history on the facts, not actually on the demographics themselves. And so they don't care if they wipe history away from the demographics table. But what they do have to do is they have to keep the ID, so that way they can go ahead and specifically impact downstream systems. And so there's actually, this in itself, by the way, is a longer discussion. So if you want to chime on that, by all means, we can definitely do that as well, because I'm more than sure between myself and Simon, we can probably do a full session just on the tricks and trades of redaction in GDPR. So yes.
I mean, referential integrity is important, y'all.
Yeah, yes. All right, so that's it for today. We apologize for not being able to tackle all the questions. We probably, into prototypical Simon and me, we probably did rat hole a little bit in the beginning, so apologize for that. But please do join us on Delta User Slack. You can go ahead and ask your questions there. We're both Simon and I there pretty regularly anyways, and we'll be here next month anyways as well. So without further ado, we're going to end today's session by going ahead and doing our little splash screen. So anything else to add before I go do that, Simon?
Oh, no, just gonna wave.
All
Thanks
right.
for coming all. Send us more questions.